This is day 12 of Advent of Code 2024 Done and Go, and this challenge is called Garden Groups. Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each section of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map, the puzzle input, of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching horizontally or vertically, they form a region. So for example there's A, B, C, D, E. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area of a region is simply the number of garden plots the region contains. The above maps type A, B, and C plants are each in a region of area 4, the type E plants are in a region of area 3, and the D plants are in 1. Each garden plot is a square and so has 4 sides. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. The type A and C plants are each in a region of the perimeter of 10, B and D have 8, and D has 4. Visually indicating the sides of plots in each region looks like this. So plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. For example this. The map above contains 5 regions, one containing all of the O garden plots, and the other 4 each containing a single X plot. The 4 X regions each have area 1 and perimeter 4. The region containing 21 type O plants is more complicated. In addition to its outer edge, contributing a perimeter of 20, its boundary within each X region contributes an additional 4 to its perimeter, for example perimeter 36. Due to modern business practices, the price of fence required for a region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. So area 4 times 10 fences is 40, area 4 times perimeter 8, 32, and so on. So our total price for all this is 140, then total price for all this would be 772, and we've got this larger example where there's a bunch more individual regions that would come up to this price. Okay, so what is the total pricing of fencing all regions on your map? Okay, interesting. Ooh, that is a very large map. So my first thought is, let's say we start here. We're then going, basically exploring through, trying to find what of the same letter is touching our current one. So we'd do this, then we'll add the coordinate to the map. So for this one we'll explore, we'll go, say we go right, and then we go, yep, this is I, keep going right, and then try right, nope, that's you, can't be that, down, yep, that's this. Okay, what I'm trying to say is we'll do a recursive, trying to find each of the letters that are touching our current one. So we do that, we add that to a map containing the indexes. So we'd start up here, we'd find all the I's here, and then we'd try the next one. That's already in the map, we keep going. Okay, this coordinate is not in it. Then we do the same thing again. And then figuring out the perimeter would be kind of, I think that would be easy. So you go through each coordinate and you go, okay, what are my neighbors? To the top, it's the same. To the left, it's the same. To the bottom, it's the same. To my right, it's different. So this would have a perimeter of 1. Then if you go to one where it's completely surrounded, there's no perimeter. If you go to the top left, well, there's nothing above it, nothing to the left of it. So straight away it starts with 2. Then you go to the right, same, to the bottom same, and for this one here it would be, okay, to my left is outside the bounds, so straight away it's 1, but then to the bottom and then to the right is 2 different ones, so then that would be perimeter 3. So I think the perimeter part is easy, it's more actually like building it. So let's get started. So of course we're going to need a grid, and what we'll do, grid is equal to make, this is square, rows, rune. And then in here we put lines 0, which is a row. Then we do for I line in range lines, grid I is equal to rune line. Then of course we need directions, which is list of 2 ints. So we would have 1 0 -1 0 0 1 0 -1. We then need to keep track of every single one we have, so there's 2 aspects, so every single one we have visited and have recorded, and then every single one we've visited within like the current loop. So this would be visited. Let's make it a map. And this will be to int. Wait, what's the syntax for this? Is it this? Bool. Okay, that's where we went wrong. And we now should do make. And now we need the function for this. So let's do var explore, and this is a func which takes in row int, column int, and what exactly is this? It's okay, we'll call it a plant of rune, and for this we now need to actually define what it is, what it does. So this is equal to func. Actually, we also need more than this. We need to be able to group each of... Actually, we can do that later. So output will be for the cost. So let's say we do this. Let's do for dir in range directions. And we need to do new row equals row plus dir 0. And then same thing, but now for column. And if new row less than 0 or new row greater equal to length of grid, or the same thing but now with the column, then we just need to continue. Actually, so I was thinking it would be a bit different the way we did this, but so I was going to set it up as being recursive in here, but then I realized that, well, outside of this we're going to be iterating through the grid and running this explore, but within this explore we're adding the coordinate to visited. So I was thinking we'd have to manage or maintain the different individual groupings, but we don't actually need to do that. We just need to handle it all in here. So we just run it, the entire thing within this one execution, finding all the nearby plants, and then we could actually return. What do we want to return? We can return the actual output. So we calculate the area inside of here. We calculate that, and then we just do that. Okay, so let's start with area equals 0, perimeter equals 0, then we would return area times perimeter. And what we could do, we could create a queue in here. So this will be a queue which is a list of list tree ints, and then when we're going through, we're going to start off with this first index. We're going to see which of the neighbors are also the same plant type. We add that to the queue. So what we'll actually do, queue is initialized with row col. So this would be for length of queue is greater than 0. We would then work on it. So current plant is equal to queue 0, and then queue would be equal to queue from 1 onwards. And because we have a plant here, the area would increase by 1. And now we get to this part for this, and this would be current plant 0, current plant 1. And then in here we check to see the surrounding plants. So we'll do if grid new row new col does not equal plant. This means we need to put a fence there, so perimeter plus plus, and then we'll just continue. And then down here where it is the same plant, we do if grid new row. No, this isn't what we're doing. We need to do if not visited, then with to int new row new col. So if we haven't visited it, we then add it to the queue. We also need to, for visited, do visited this one equals true. Then we also need to go down here. Actually no, we don't need to, we do that here, visited. So we go to we do a starting location. We then area perimeter, we've got a queue. While there are things in the queue, we have visited it, get the plant, area increased by 1 because of that. Then we try each direction. We are creating the rows and columns for this. We check to see if it's within the bounds. Oh, I forgot about this one. I said before, if it's next to like the outer bounds, then that's a perimeter. So we do that. And I think that's it for this, but now we need to actually do for row equals 0. Yeah, that's fine to call it. Row is less than length of grid, row plus plus. And then we do the exact same thing, but now for column. So col, and length of row. We then do output, no, first we need to check if not visited. If not visited, row col. We then do output plus equals explore row col, and then grid. This would be into row col. So let's run that and see if we've got it working. I've got an error. Why is that an error? I think I'm missing one. Oh, okay, that's why. Cannot use grid variable varine. Oh right, grid. So row col. My bad. Now run it. Invalid argument index lines variable of type string must be integer. Where did that error happen? Okay, I'm not actually sure. Is it up here? Lines variable type string must be integer. Length of lines. I think. What's wrong here? Non-name grid 1 on the left. Okay, that needs to be that. Hopefully that's all the errors I've made. Okay, I'm going to stop that because it took longer than I thought it would. Let's try it with this input. Okay, well we've got an error. And I did new col instead of new row. So let's run that. Okay, yeah, seems like we've got infinite loop somewhere. Let's do a breakpoint here. What's our queue looking like? Okay. Well, it looks like it's doing like multiple levels of queues or something. Okay, I'm not sure. Where do we go wrong? So area, parameter, got our queue. We are initializing a list of our lists with size 2 ints. We start with row. We then grab that and do this. Then we do that. Okay, so I realized, so there could be 4 items in the queue. And then we go from one and we start exploring around. We then get to one which is already in the queue, but visited is only happening here. So let's first do this. And I was also doing the wrong value for visited. Okay, do this. Then we go to here, and we'll do new row, new column. So I think that should work now. Get rid of that breakpoint and continue. 140. Was that the number? I can't see it on here. Was there a 140? Yep, it was 140. So now we'll switch back to our actual input. And we got 1375574. So let's submit that and see if it's correct. And it was correct. So let's go on to part 2. Fortunately, the elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. So consider this. The region containing type A plants has 4 sides, as does each of the regions containing B, D, E, while C is complex and has 8 sides. Using the new method of calculating the region price by multiplying the region's area by its number of sides, region A through E have prices 16, 16, 32, 4, 12 respectively. The second example above, full of X and O's, would have 436, and this one would have 236. Okay, so that makes sense. So I spent pretty much all day trying to figure out part 2, and there's no way I'm going to waste my time editing it just to have all my code deleted and try write it again and delete it again. So I've got code here which I'm going to go over, and I definitely didn't figure it out myself. So the original approach I was going to do was we go to an edge and we record the direction of which ones are not of the same plant. We do that for all of the edge ones. We then iterate through that list and we go, okay, this plant here has a side facing this way. We are now going to go right to the left and find the same plants which also have the up above it and the other directions not of the same plant. So I had that code, and for some reason it would just not work at all. When I would test it on when I tested on this example, it would work. But then when I would test it on other ones like this, or there's that E1, it just would not work, and I could not for the life of me figure out why. Because there's nothing in the code which I thought was wrong. So I had to give up on this one and look online, try to figure out So the solution is based on what is it, like the number of corners matches the number of sides you have. I think that's how it works. But that's essentially it, and the code I have, I'm going to try to go through it. So there's some of it which I don't fully understand, but I'm sure we can get through it. So most of it stays the same. Create the grid. We've got directions. We then have this outer corners, and then we have this check inner corners, which is used later on. So we continue down. We keep track of which ones we visited. Going through the grid, row and column. We've already visited it. Skip it. Grab the current plant, and we record the areas and corners. And then same thing again. We've got the queue. Grab the current plant from the queue, and then we remove it. So still doing the same thing, going to the current column and current row, adding it to visited. Oh, actually no. If we're checking to see if we've already visited. If not, we continue. Otherwise, we then go on and add it. Area ++. Corner type starts as 0. Now we're iterating through the directions, doing the same things before, creating the new row, new column. And then this part I don't fully understand. So if the outer part, if the direction is outside the bounds of the grid, or it's a different plant, then we're doing corner type plus equals, and it's a bitwise, I think. Okay, so we're iterating through each. Okay, I understand now. To find out what type of corner it is, we're going through and we're doing this 4 times. So let's see, corner type. If it's a place we haven't visited but it's the same plant type, once again add to queue. So with corner type, we're going to outer corners, and then we are retrieving the corner type. Okay, I see. It's using the I here. So if we go to corner type, oh no, not corner type. If we go to outer corners, so it's using bitwise based on that. So the directions was changed so it goes around 90 degrees. So based on which sides are empty, not of the same type, determines the type of corners it is. So that's kind of the math it's doing, which is pretty interesting that's a way of doing it. So I definitely wouldn't have thought of that. But if we go back here, so we've got outer corner count. Now we need to do the inner corner count. So we're going over check inner corners and corner type. So based on the type of corner, these are the coordinates of grid directions that we need to check. So we're checking the corners, doing new row, new column again. Same thing, if it's out of the bounds, just continue. Otherwise, if it doesn't equal the plant, then inner corner count. Then we're combining the 2 corner counts together, and like I said before, the amount of corners you have in the shape is the same as the amount of sides you have. So now you're just doing area times corners and adding that to the price, which on this example was 236. So now it's time to go to our actual input and run it. We have this number 830566, and that is the correct answer. So that challenge escalated very quickly in comparison to the ones we've already had for advent of code. The previous ones have been pretty straightforward, but then this one just, I don't know if it was me doing an issue, but I just could not for the life of me find out what was wrong with my previous code. Like, I'd set it up correctly, I think I had, where I would record what I had it set up to do was it would look at, like, go through a shape, and so this whole top row would be in the map, and it would have the values of the direction. So each of these would have -1, 0 as part of its grid. We'd start on this one and do -1, 0. Yep, that is outside of the bounds. We would then go to the right. Are you also out of bounds? Yep. Keep going. Are you also? Yep. Keep doing that until the very end, and we'll go, are you the same type? No, you're a different type. Okay, you're not part of this anymore. And then we'd go in the other direction. So let's say we started on this coordinate right here. We would go to the... Actually, it doesn't make sense. Let's say we were here. So we'd start on this one, and we'd go, okay, the one above me is not Y. And we'd keep doing cross, you're not Y, you're not Y, you're not Y. Then we'd go to the right, okay, you're you aren't Y. So we know, okay, this is where the side ended. Then we'd go back to here, and we'd go in the other direction. Keep going until here. Okay, you're Y, yep. But you're also a Y above. So that means this side has now ended. Like, I was recording that, and it would, mostly work. But then I'd debug it, I'd check the coordinates that were saved, and it would change each time. Like, sometimes, let's bring up an example one. Let's see. Let's go back to the advent calendar. Let's go back to here, and which one do I want to look at? Let's say this one. Like, I'd run it, and With this one especially, I would get, I think it's meant to be 12 corners for this. Okay, well, I'm running it, so I think this one had 12 corners and it was like, what, 17? Yep, 17 times 12, whatever that number is. But I was getting 11 sides. And I'd check, and each time it would be like, okay, this one is missing, this one doesn't have this one out here, or this one doesn't have here, and it made no sense. But I'm glad I was able to find a solution that worked, because I'm tired and I've had enough of doing Advent of Code. So if you like this video, make sure to like and subscribe.